Eccoci qua, allora benvenuti tutti quanti. Oggi parliamo in questa sessione di time series for relational people, quindi l'idea è quella di darvi un po' un overview dei database time series per voi che venite dal mondo relazionale. Proviamo a capire insieme che cosa sono questi database time series. Un grande ringraziamento agli sponsor che ci aiutano a allestire e mandare avanti queste giornate. Senza gli sponsor queste cose qui non funzionano. Io sono Gianluca Sartori, fondatore di Quantum Datis, consulente indipendente SQL Server, lavoro con SQL Server da tanto tempo, dalla versione 7, correva l'anno 1998. Data Platform MVP, lavoro come DBA presso una scuderia che forse non ha un team principal in questo momento. Se volete leggere il mio blog lo trovate all'indirizzo spaghettidba.com, il mio handle su Twitter è @spaghettidba. Bene, allora, di cosa parliamo oggi? Prima facciamo un po' di noiosa teoria. Studiamo un po' cosa sono i database time series, andiamo a vedere quali sono le caratteristiche dei dati time series. Fermi tutti. Does anyone here speak anything other than Italian? Yes. Let's switch to English. So first we will see what are the options on the market, and we will see that the main product in this area is called InfluxDB. So we will have a look at InfluxDB. We will see how it works, what are the core concepts when working with InfluxDB, and we will see how to get it, how to install it, and then we will see how to start working with this data. We will see how to query the data, how to get the data into the database in the first place, and then we will see some practical uses of InfluxDB. Well, let's go. So, first things first. What is a time series database? And what is a time series data? It is data that comes with a time attribute. It's that simple, really. But the idea behind is that you get this data with a timestamp attached because you want to observe something. What you want to observe is the change over time. So what you do is you use for this a specialized time series database. And a time series database is a database that is optimized for working with time series data. So it uses internally optimizations to store the data efficiently, to retrieve the data efficiently, always keeping in mind that the main concept is that you have a time attribute every single time attached to all your data. So how do you obtain this time series data? This is data that is everywhere nowadays, and you can get it from any source. You can get it from, things like the atmosphere temperature. So you have sensors that produce that data for you. You could have it from anything that is not really related to any physical object, but it could reference things like stock prices or things that don't really have physical existence in the physical world. But it could also come from IT entities like computers. So you could be observing some metrics like CPU usage or disk response time. All these data is saved in series, and what you want to do is plot these series on a chart to observe the change over time. So what you have is your time on the x-axis, and on the y-axis you get the metrics that you want to observe. And obviously we have an entity, which is what we are observing, and we are extracting some metrics from that entity, and we have some tags that decorate, that add more information to the entities that we are observing. We can have two types of time series data. We could be dealing with metrics, and this is data that is evenly spaced over time. So that means that we receive the data that we are observing at regular intervals. So it is evenly spaced between the samples. Another possibility is to get the events at random times. So as soon as an event is happening, we have the data and we record this data in our time series database. So in this case, what we are dealing with is events rather than metrics. And both approaches are also valid, and it all depends to what you are dealing with. So the main question is, how is this type of data? Yes? Yes, that's also possible. Everything that we are observing can come at any time when you're dealing with events, and multiple events will be multiple data points at the same moment, at the same time. It's pretty unlikely because the precision of time can be anything, can also be down to the microsecond or the nanosecond. So it is pretty unlikely to get two events at the same exact time. When you do metrics, you do the observations, and all the numbers that you extract at that particular time will be decorated with the same exact instant in time, so down to the nanosecond, but it is pretty unlikely with events. Good, so the main question is, how is this data different from the regular data we are used to, the data that we treat every day in relational databases? It is actually pretty different, and it all comes down to main features, main characteristics of this time series data. So when we're dealing with the normal data that we have in relational databases, we're used to having entities, and entities are related to other entities. So we have foreign keys and all that kind of stuff. That doesn't apply at all to time series data. What we have is metrics observed at a particular instant in time, and this comes with some features. It could be a continuous stream of data that we receive in time order. So imagine that you have a sensor, and this sensor is emitting some data. It observes from, I don't know what, a thermometer or a Formula One car. And this data is gathered in time order. The data is gathered now and uploaded to your time series database, and the new sample is uploaded in 5 minutes and uploaded to the time series database. So this data arrives at the database in time order. Every sample is always after the previous sample. And another feature is the fact that this data doesn't come in one sample at a time with just one metric inside. It is usually batches of data. So it is large chunks of data that we process when we receive this data. Imagine a sensor that measures temperature every second. Well, it doesn't really make sense to measure temperature every second, but let's pretend for a second that it makes sense. It wouldn't be wise to upload every measurement every second. A wiser way of dealing with this is caching all the samples locally and then upload every 1 minute, every 5 minutes. So you have a batch of values that arrive at your time series database altogether. Another thing that is usually what happens with time series data is that you are dealing with high volumes of data. Imagine having multiple sensors spread all over the world that measure temperature or measure different metrics that come from, let's say, a Formula One car. And you want to store this data and you want to keep it for a long time, let's say months or years, this becomes pretty quickly high volume data. So it is very common to deal with millions or even more easily billions of data points in your measurements. Another thing that is interesting is that the data doesn't change over time. It is measured at that time and it never changes. So that allows for some interesting optimizations that don't apply to the relational data. What we want to do with relational data is we want to change it every time the underlying entities need to change. And this doesn't happen with time series data. When the entity changes, we just upload a new sample, and the old one represented the state at that time. Another thing that we usually want to do with time series data, we want to delete large volumes of data when the data goes out of scope. Probably doesn't make sense to retain the data forever. Example, when the championship season for Formula One ends, there's some data that we are not interested in. So what we can do is delete the data when it goes out of scope. Let's say we keep it for 1 year, and after 1 year, we simply delete the data. So a time series database needs to be able to cope with deleting large chunks of data without killing the database. And another thing we may want to do is downsample the data. It is interesting to keep high-frequency data for the period when it makes sense to perform some troubleshooting when you really need the high-frequency data. But when it is, let's say, after 1 month or after 3 months, it doesn't really make sense to keep the high-frequency data. What you may want to do is downsample that data and keep an average, the maximum, the minimum, and aggregate this data rather than every 1 second you keep a sample that represents 5 minutes or 10 minutes or 1 hour or whatever makes sense to you. And maybe you keep that data for a longer time, let's say 5 years, just the averages, and the high frequency data, you keep it for 1 year. Good, so the question is, should I use SQL Server for that? The answer is, well, it depends. Relational databases are designed for dealing with other types of data. So they're designed for dealing with relational data, and they do it pretty well. Some of the things that we described, some of the features of time series data don't really fit well with relational databases, especially if you skip some optimizations and you try to use normal tables without thinking up front what you will have to deal with. So example, if you use a regular table and you store billions of rows inside, yeah, things can get pretty complicated quite quickly. So you would probably need to use something like a column store table. Clustered column store index compresses data very efficiently, so that's probably what you want to use. You don't have retention policies enforced in a relational database in SQL Server. So if you really want to delete billions or millions of rows without locking the whole table, you probably want to use partitioning for that and delete the whole partition. You just unbind the partition from the table and you throw it away. And also, it is not easy to perform some time series manipulations on the data, like creating windows of data samples of a certain width, like 5 minutes, 10 minutes. So grouping by time is not really supported on SQL Server. Well, actually, it wasn't supported because SQL Server 2022 introduced new time series features for T-SQL. And one of the things that it introduces is partitioning by time. We will see that there's a function called date bucket. You probably heard of that from the session from my homonymous Gianluca. And also, there are some features that were inherited from Azure SQL Edge that now are part of SQL Server 2022 that help you deal with time series data. Azure SQL Edge is a specialized version of SQL Server that is designed to run on low-end machines like Raspberry Pis or any other small machine attached to censoring data from the edge, so I don't know, industrial machines or stuff like that. And the idea behind is that Azure SQL Edge is part of the Azure offering, so it is low-end machines that do some kind of aggregation and deal with the data at the edge and then upload this data to the cloud. It had some time series specialized features, and now these features are coming to SQL Server 2022. Good, so if we decide to use something different from SQL Server, we need to understand what we want to use. And one way to understand what is the market leader right now is to turn to these guys. They're called DB engines. What they do is they do some ranking of what is popular and what is not in one particular area. And they use data from, let's say, Stack Overflow questions or forum questions or blog posts. Basically, they scrape a lot of sources and they try to rank technologies in order to make these tables. It's not 100% scientific as an approach, but pretty much gives you an idea of what is popular. And at the top right now, this is from April, at the top we have InfluxDB. There are other options, of course. There are Prometheus, we have Graphite, we have TimescaleDB, which is a very interesting option. This is basically a specialized version of, Postgres, and it has time series capabilities, so you get the best of both worlds. It can run both relational and time series data in the same database. So that's quite interesting. But yeah, at the top, what we get is InfluxDB. And InfluxDB is what we will describe in this session to make all these things we discussed more concrete. Good, so InfluxDB is, as we have seen, the top popular option for time series database nowadays. It's open source product, an open source project that comes from this company. It's called Influx Data. And this company produces different tools in this stack. It's not only InfluxDB, it produces also Telegraph, which is a recording agent that is used to gather the data from multiple sources and can upload this data efficiently to an InfluxDB database. It also has a built-in engine for analyzing the data, which is called Capacitor. It is now embedded in InfluxDB itself, so it's not a standalone product now. And also has a graphing tool that is used to create dashboards on top of the time series data. But what we'll focus on today is InfluxDB, so the database itself. So as we said, it is time series database designed with time series data in mind. So it uses storage, an optimized storage engine to store the data in, surprise, surprise, in a columnar fashion. So what we can do with InfluxDB, we could also be doing that in SQL Server when using column store compression. Another thing that it does is that it uses built-in retention policies. So every time you create a measurement we will see that a measurement is the equivalent of a table in the time series space, you can decide to which retention policy it gets assigned. One of the things that contributed massively to the success of InfluxDB is its licensing. It is very permissive, so you can use it in your own projects, and you can distribute it, and you don't need to pay any fees to Influx data. It is written in Go, which makes it cool, but also makes it very efficient, because Go has a very efficient runtime, and also it means that it makes it very capable of going to any possible platform. So it runs on Windows, on Linux, on macOS, also on containers, so Docker and Kubernetes, and also on small, not very capable machines like Raspberry Pis. So pretty cool. One of the very early decisions that we need to make when dealing with InfluxDB is what SKU to run. So the easiest option is just to go with the cloud. We get a PaaS offering from Influx Data itself. They host it, they give you a slice of their computing capabilities, you get a database, and you start dumping data to that database in the cloud. You don't have to do anything. But that's not for geeks. So what we want to do is use on-prem version of Influx data, of InfluxDB. What we will have to decide now is whether to use the latest and greatest, which at the time is 2 point something, or go with an older version. The older version is 1.8, which is currently deprecated, but it has some features that make this more, I would say, accessible for people with a relational background. So the language to query the database is similar to SQL. It is easier to understand for us. Once we have the basic concepts in the bag, it's easy to move to version 2 as well, but it's easier to approach it from version 1. So even if it is deprecated, we will go with that for these demos. Good, so we have to understand how to design a database properly, and we need to understand how the data is stored inside an InfluxDB database. So what we want to observe, as we said, is this data and how it changes over time, and that is what we will store in measurement. Everything that we observe, every entity that we observe and produces data will get its own measurement, which is the equivalent of a table in InfluxDB. Measurements are made of fields and tags. So what is a column in the relational space? In InfluxDB, in a measurement, becomes either a field or a tag. What's the difference? So a field is the actual measure that we are observing. So let's say, example, we are observing temperature. So the actual temperature is what goes in the field. So 37 degrees, 21 degrees, 11 degrees, and so on. The tags is additional data that allows us to group and query the data, group and filter the data. Example, it's a temperature for room 7. So room 7 is an additional attribute that goes along with the data, and it is not the real data. It is something, it's some additional metadata that we add to the data itself. So that goes in tags. What we will get is series, which is then the values for a single field, the temperature, and we will get that over time. So when we want to find a single data point, let's say the temperature for room 7 at 2:25, we will have to give the measurement name, so temperature, room temperature, for example, the time, so 2:25, the tags, room 7, and the name of the field, temperature. And then we get the single data point, 21 degrees, roughly. Good. So if we try to make an example out of that, let's see that we are measuring CPU usage from SQL Server, something you probably are very familiar with. So you can get that from a DMD. It's called sysdmos ring buffers. And what we will get from that is two fields. SQL Server CPU, how much CPU SQL Server is using at that particular minute. We don't have a smaller granularity. What we have is by the minute. And SQL Server CPU and other processes CPU. So what you get in this case is some data that, if you want, we could store in a relational table in SQL Server itself. But what we want to do instead is store it in InfluxDB. Let's see how we do this. So, as we said, this needs to go to a measurement. We can call it CPU history, so that's the name of our measurement. And this will contain two series, one for SQL Server CPU and one for other CPU. So it becomes two separate series. One will be CPU history for SQL Server CPU, and what will be CPU history for other CPU. So these two get stored independently. And it's the logical concept of the measurement that keeps the two together. If we add tags, things become even more complicated. Let's say we are not measuring CPU just for one server, but we're doing that for two servers. One is called CRM, the other one is called accounting. So what we get is that at a particular time, let's say at 8 a.m., we will get one value for SQL Server CPU and one value for other CPU. We will also get one value for SQL Server CPU and one for other CPU for the CRM server. So this becomes four separate series. One series for accounting SQL Server, one for accounting other, one for CRM SQL Server, one for CRM other CPU. So this means that the more distinct values we get for the tags, the more series we will get. And this is a familiar concept if you had to deal with column store data in the past. So as we said, the series are stored independently, and one of the things that decides the success of how we will store the data inside InfluxDB is the cardinality, so the number of distinct values that we will get for the tags. The higher the cardinality, the more series we will get, and thus that is less efficient than having a smaller cardinality. Yeah, does it look familiar? It does. It's what happens in column store indexes. The smaller the cardinality for your columns, and the better the column store compression. So this gives away what is under the hood. The engine in InfluxDB is called TSM, and it is a modified version of LSM, which in turn is the storage engine from Cassandra, which is one of the most popular column store databases out there. The guy who came up with InfluxDB basically took the engine from Cassandra, adapted it for time series data, and made it a very successful time series engine. So this lives on some assumptions that allow some interesting optimizations. So everything is stored in series, and it is all organized for data that is never updated. It is always appended, and this allows to perform very good aggregations and compression. Good, so enough talking. Now we do some practical stuff with InfluxDB. We will have to download it and install it if you want to use it. It's easy to do that. It's an open source project. All you have to do is go and download a zip file. We extract that zip file to a folder, pretty easy. And then we have the binaries. Once we have the binaries, we just need to check a couple of things in the config files, or maybe not. We can also run it as it is. It just runs even if we don't touch the configuration. And then we can probably run it as a service, and that's probably what we want to do. So let's do that. So for these demos, I am going to use, oh wait, I need to do this correctly. So I'm going to use Azure Data Studio, but I need to run it as an admin because I will start services and stuff like that. Okay. So what we will use for the demos is a notebook. A notebook is a very interesting feature of Azure Data Studio. It allows you to have cells in a document that allow you to have text and code together. So it is good for demos like this one. So you can download this. It explains what we are doing, and the text cells and the code cells will just perform some actions. These are going to be PowerShell code cells. So first of all, we need to set up the environment to make sure I'm not cheating and I don't have any ready-made databases here. I'm really collecting some data and really working with it. Good, so what we will do is download InfluxDB, and I'm really going to do that. I have the zip file already here. We're saving some time. All you have to do is expand the zip file to a directory. We'll do that on ctick, and then we will see what we are getting. So here, you can see we get some executables, and InfluxD is the daemon for InfluxDB, and then we get some other tools. This is the command line interpreter, so the CLI for InfluxDB is this influx.exe. And the other two, I have no idea what they are. You have a config file, you can fiddle with it. We're not going to do that. We're going to accept the defaults for now. So let's try to do something with that. Good, so if we want to run InfluxDB, it's easy. All we have to do is run the executable that we have seen. So this influxd.exe is what we need to run. So let's try that. If we do that, a console application appears. We got a nice text splash that says InfluxDB, and now it's running. But yeah, if I close this window, it goes away. So we probably want to run it as a service. Oh, wait. So in order to run it as a service, we will use one small utility which is called NSSM. It stands for Non-Sucking Service Manager. Why? Because not all applications can run directly as a service. They need to have some handles to stop, start, and pause the application, and not all executables have that. So if you want to run an executable that doesn't have these handles, you need to use a service manager, which is a wrapper application that needs to run the other application that you really want to run. Microsoft used to ship one, which was called SRVNE. Does it ring a bell? And you know what? It used to suck. So a guy came up with a non-sucking service manager, which does the same thing and doesn't suck. Good, so if you do that, you can download and install this non-sucking service manager. Again, it's a zip file, and it contains just an executable. And what we will do is we're going to run that. So we can start nssm.exe, and we pass install as the action and InfluxDB as the name of the service we want to install. So let's try to do that. And a small window appears. All you have to do is select which is the executable you want to run. So influxd.exe. Let's do that. And install service. Done. Easy peasy. So now, if you want, we can start the service. So let's do that. We're going to do get service and start service. And now the service should be running. Let's verify that. So services. Is it running in Flux? Yes, it is running. It is running. Good. So now we can start to work with it. We could run queries, store some data, but before we do that, some more theory. So, in InfluxDB, we store the data, as we said, in hey, it's all broken. Oh, wow. Okay. Well, the idea is, the layout is completely broken. I don't know what happened. So, in SQL Server, what you do is you have schemas and you save your tables in schema. Well, it doesn't work like that with InfluxDB. You have measurements, and all the measurements can belong to one or more retention policies. And the interesting bit is that the same measurement can belong to multiple retention policies at the same time, and it is the same measurement. And the fact that measurement exists in a particular retention policies is decided by the dates in the data points you are saving. So if the data is in the short retention policy, goes to the short one. And you can have it in the long or in the temp one, depending on the setting that you do for your retention policies. The things have changed quite a bit and become very confused and confusing in InfluxDB2. Now databases are called organizations, because why not? And the retention policies are now called buckets, because again, why not? But yeah, it's just different names to make things more confusing. Okay, so if we want to write data to an InfluxDB database, we will have to use the API. There's no insert command in InfluxDB. So depending on the version we are using, version 1 or version 2, we have an API for querying and an API for writing, and we have the compatibility with the other versions. So we can have V2 compatibility in V1 and V1 compatibility in V2. And the main difference between the two, especially when it comes down to querying, is the language that you will use. So for querying V1, there's a language which is called InfluxQL, and as the name suggests, it looks a bit like SQL. And for V2, we have a weird language that is called Flux. The other possibility is to use the CLI to interact with the database. So you can go from the command line and say, okay, I want to insert this data in the database, and do that using influx.exe. So let's try to do that. So again, we go to this InfluxDB, we have it running, and we will create a demo database. Now it's called demo. And if we want to write the data to this database, we're going to have to use what is called the line protocol. Why didn't I show that? Okay, the line protocol is like this. You need to specify the name of the measurement, then there's a comma, then you need to specify the tags, and there's a space, and then all the fields separated by commas. So SQL Server CPU equals 1, other CPU equals 7, and then you have the timestamp. The timestamp is a Unix epoch in UTC format down to the nanosecond. So pretty easy. Let's try to do that. So if I want to run the data here, I'm going to write some line protocol. I'm using small PowerShell function that I wrote. You can have it, it's in the demos. And I will use that to insert some data. Right, so I have this demo database now, and nothing is working. What's happening? There we go. Okay, this is the output. So when I run this select star from CPU history, it shows me that I have actually inserted some data. And it contains this other CPU and SQL Server CPU that I inserted here with this line protocol for CPU history, with that format that I showed you, the line protocol format, and the same can be done from influx.exe. You have the insert command, but the CLI basically invokes the API under the hood, so it doesn't do it. There's no insert command, actually. It's a command for the CLI, not for the database. Good, so what we get is we have these two data points inserted, one for accounting, one for CRM. Good, so what we probably want to do is not insert the data points one by one. What we want to do is insert the data in batches. So what we do is we separate line protocol lines by a new line character, and what we get is batches of data. So it looks a bit like that. If we insert data like this, insert write line protocol with all these batches of data, what we get from CPU history is, oh come on, why isn't it showing anything? Okay, now what you get is the data that is inserted like this. So we can insert batches of data. Probably what we want to do is not even this. We don't want to insert batches of data directly. What we probably want to do is rely on an agent that does this for us. So it observes the entity that we want to observe and extracts the data and writes the data to the database directly. Still using the API, still using the line protocol, still writing in batches, but it knows already what to do. So we don't have to write code for that. Telegraph is the agent that comes with InfluxDB, and it allows you to attach to multiple possible sources, including many objects that are commonly found in IT infrastructure, like databases, operating systems, I don't know, web servers, and stuff like that. So you have input plugins for any of these entities, and you have output plugins for multiple possible destinations of the data. And one of these is InfluxDB. So as an example here, we can set up SQL Server as an input and InfluxDB as an output. And Telegraph is capable of monitoring SQL Server, already knows how to monitor SQL Server, contains some ready-made queries to extract meaningful information from a SQL Server to understand whether it is in good or bad shape, and writes this data to an InfluxDB database. So let's try to do that. Telegraph is again one thing we can download and install. It is again an executable, a single executable. But one thing is that you can configure it using this config command, and you can use a filter to configure SQL Server as an input and InfluxDB as an output. What you get is a sample configuration for using SQL Server as an input and InfluxDB as an output. I already know how this sample looks like, so I'm going to replace the source SQL Server with the one that I actually have here on this machine in the configuration file, and the same I will do for the output on InfluxDB. So this will create a configuration file, and we can have a look at that file together. So So if we do that, the configuration file for telegraph looks like this. We need to, oh, this means I'm running late. This tells telegraph to output the data to InfluxDB localhost port 8086. And this tells it to extract the data from a SQL server on localhost port 4033. So if we do that, we can test the configuration file. If it outputs a lot of line protocol lines like it did, it means that it's working. So let's delete that. And now we can run it and telegraph. It's now here on its own window. And it says, okay, I have this query to work on. They will gather different things like performance counters, schedulers, memory clerks, SQL Server CPU, and so on. And it will write this data to an InfluxDB database. Let's check this is actually happening. If we connect and we go to the Telegraph database, which is the default database for Telegraph, and we query show measurements, so show me the measurements, it will show these measurements. So it is actually writing this data to these different measurements in InfluxDB. So we have one for CPU, one for performance counters, one for requests, and so on. Good, so now that we have all this data in InfluxDB, we could run some queries, right? So let's do that. Well, we have two options, as we said. Version 1 supports InfluxQL. It is something that looks like this. It looks a bit like SQL. So we have select, from, where, group by, and so on. Looks a bit like a regular SQL. The other option is Flux. That's for version 2. Flux, well, it looks like Custo. The question is why? So, yeah, because why not? Yeah. So we've been having SQL for 50 years, and it worked wonders. I actually did not feel the need for another language to query data, but again, that's probably just me. But the good news is that InfluxDB version 3 already supports SQL, so they went back, changed their minds again. It's only in the cloud, but time 1 year it will come to on-prem again, so it's going to be fun. So InfluxQL, this is the syntax. As you can see, it looks like SQL. It has some interesting features like limit offset, slimit, soffset, the time zone to switch time zone. And you can group and fill data. This is interesting, and this is one of the things that now you can also do in SQL Server. Good, so let's do some queries. Right, so simplest as possible. Select star from measurement, which shows the data in a measurement. So no surprises, gets you all the data, all the fields, all the tags, so no surprises. You always have the time here. Good, so let's do something more meaningful, like select from where. You can filter on tags. You cannot filter on fields. You can only filter on tags. Oh, sorry, you can filter on tags. You cannot group by fields. So let's do that. Select star from CPU history where 7name equals accounting. No surprises, just like regular SQL. So the rest of the data is not shown. It's filtered out. No surprises. Some interesting quirks. It's case sensitive. So that means that select from CPU history where 7name equals accounting lowercase will not work, so no data returned. But the interesting thing is that you can also do select a field which is not in the measurement from that measurement, where another field that doesn't exist equals something that doesn't exist. And it won't complain. Yeah, no errors, just returns no data. Yeah, nothing and nothing. So that's pretty weird, but yeah. one of the most interesting things that you will probably do all the time is filtering by date. So you have some shortcuts like now minus 1 day, now minus 1 hour, now minus 1 month, and all of this works. So it is pretty good to have this already available. So it is filtered by just the data for today. And you can see that at midnight I was inserting several data in the database. What else? You can group by columns. So in this case we are calculating the average of the CPU. It is called mean in InfluxQL. So select mean SQL Server CPU from CPU history, where time greater than now minus 1 day, group by 7A. So this will calculate one row per server. So the average CPU is 44 and 34. Yeah, the performance is really, really good. Yes, it is super responsive. Another thing that you probably want to do is not just group by a column, so a field or a tag, but you will probably want to group by time. So you create windows of time of a particular size, let's say 10 minutes. So what will happen here is that you get, oh well, we only have two windows, so 1440 and 1450, but as you can see, it calculates the average inside this window and inside this window. So what you get is one window of a particular size. You can do the same in SQL Server by using the date bucket function. If time allows, I will show you. One of the interesting things is that you can select how to fill the results when there is no data in that window. So, example, group by time, 1 hour, fill now. This will fill the non-existing, the empty windows with the null values. So, example, this is for 1 day. So, starting from 24 hours ago, I will get different windows. It starts yesterday at 2, and it goes to today at 2, and I don't have data from the previous windows, so it gets null. You can also decide to fill with a value. So let's say I'm going to fill with 0, so now we get 0 in all the windows that don't have values. So that's pretty neat. I'll put null again, otherwise it messes my demos. Other things you probably want to do is limit the values you get. So you can do that with limit and slimit. The difference, so if I do limit 1, I get 2 values. Why? Because I have 2 series. One for accounting, one for CPU. So I will get 1 value from each series. If I want to limit the number of series that I get, I need to use slimit, and that will get me just 1 value. So it's some peculiarities of the language. Good, so what if we want to modify the data in InfluxDB? So it is insert, update, and delete. Insert, it doesn't really exist. As we have seen, there's an API, there's no insert command. That's a command for the CLI. So it's the endpoint that takes care of inserts. Update, it did not exist. There's no need to update the data. As we said, the data is append only. If you really need to update the data, what you do is re-upload it with a new value. So it overwrites what's already in the database. It needs to match exactly the timestamp and all the tags. And then we'll identify the single data point, and then you replace the values. As you can imagine, this is column store data. So same as in SQL Server, if you resurrect a row that has been already compressed, it is additional data, so it contributes to the size of of the database because it is not compressed, and that segment will need to be compressed again. Delete works the same as SQL. It doesn't really delete the data, marks some data as deleted because, as we said, as this is column storage, so it just marks some rows as deleted. So let's try to do that. So delete. First of all, we're going to do update. We had some values. We're going to change other CPU to 0 for all the points. So other CPU will get 0, and we do that by re-uploading the data. Let's do that. Has it been updated? Yes, it has. Other CPU is 0 for all the data points that we passed in with 0. Delete. Yeah, gets rid of all the data. So now if we select from CPU history, it is empty. So delete works the same as in SQL Server. Cool, so other things you want to do probably is applying retention policy. The default is keep forever. You can create different retention policies and say how long you want to retain the data. So keep 1 year, 2 months, 3 seconds, whatever makes sense in your case. One thing that you probably want to do is downsample the data. So let's say you have data every 15 seconds in the troubleshooting retention policy that you keep for 15 days, and you have a 6 months retention policy with the data saved and aggregated, let's say, over 10 minutes. So you can do that with things that are called continuous queries in V1 and jobs in V2. It's basically Flux or InfluxQL commands scheduled internally in InfluxDB. I'm not going to show you that because we have 3 minutes. So doing this, putting all the data together, often means that you will have a metric or multiple metrics gathered by telegraph, so an agent that connects to something, extracts some data, and writes this data to an InfluxDB database. And then you display this data using charting and graphing applications. So this is Grafana usually, and what you get is the TID side, so telegraph, Influx, and Grafana. Let's try to do that. So we're going to download Grafana. It's a zip file again, another open source project. So if we do that, we get Grafana. It's executing, it's creating the database, and good, we have a Grafana server running here. Grafana is a web application, so in order to connect to Grafana, we're going to need to run a browser that connects to a local host on the default port, which is 3000. Let's do that. What we get is the login page, admin, admin, change the password, admin, admin. And you can connect to multiple data sources. And natively, Grafana supports InfluxDB. So we're going to connect to http://localhost 8086, default port for InfluxDB. We're going to connect to a database which is called Telegraph. Save and test. Yay, we have a data source. Cool. So now what we need is a dashboard. So let's create a dashboard. Dashboards are made of panels, and each panel can display multiple, one or more metrics. So let's do that. We're going to create a panel here that displays SQL Server CPU. So how do I do that? With a query with InfluxQL. I could type it. Of course, I know this by heart. No, I don't. And once you have your query, it displays your data. Yay, we have some data here. So apply. This is a horrible dashboard, but you get the concept behind. So the idea is to have this and transform it into good-looking dashboards. So, wrapping up, time series databases are fantastic for storing time series data, no surprises there. It is not the same databases that we know and we love. I suggest that you have a look, probably starting with InfluxDB. It is good for IoT problems and telemetry and everything that has to do with time series. I should have you asking questions to get a book on time series. So the two quickest persons to raise their hands will get the book. One is here, and then we have a second. Yes. I'm sorry for you, it's for Python. Good. So if you want to see all this in action and good-looking dashboards, I have a booth here in the corridor. So come visit me. I will show you how we built a complete SQL Server monitoring solution based on time series databases with InfluxDB and some ASP.NET on top, but the core is InfluxDB. Thank you very much. If you have questions, now or never, it's never because it's time over. So send me an email. Thank you.